Hi, everybody. Milk's here.
Also, MoNaCo.
And this is still Unit 7 Solutions, homework number 6.
Yep.
We are now on page 16 in your packet. We're going to talk about concentration.
Yeah, we want to put numbers on concentration. We've been saying dilute concentrated all along here, but now we want a number.
There you go. And we're not talking about think harder.
No.
No, think smarter here.
So dilute versus concentrated. Why do we measure concentrations? Because,
Well, we could come across, say, 12 molar acid,
right.
which is going to severely burn you.
But you wouldn't know that unless you understood dilute versus concentrated. Right. That 12 molar, bigger number, greater concentration.
Yeah, why don't you take a second to show us why 12
Sure.
molars bigger than 1 molar. So 1 molar acid is something more like MoNaCo and I would make you guys in lab that you can deal with. So he's going to make these 2 boxes. We're going to say
the same size.
Yep, they're the exact same size.
And so for the 12 molar one, I'm going to draw that there. For the 1 molar, I'm going to draw that there. And what this means, let's say it's got the same amount of liquid in there, right? Both of them got the same amount of liquid in this container. 12 molar one would have 12 moles
Of solute,
the stuff that got dissolved in the water.
Right.
And what I'm going to show you that is I'm going to put basically 12 dots.
There you go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Of course, those are going to spread out and bounce around the solution the best they can. They're aqueous now. Versus
1
molar. Now, it's the same compound. It's still dissolved in water. It's still aqueous. But which one is going to be more dangerous or more effective or more concentrated?
Yeah, simply more.
So concentration numbers, measuring them, calculating them, is finding out which solution has more, which has less.
Sure.
Concentration. And there's 4 different units of concentration that you should be basically familiar with.
Right. The first 2 are the big ones that we're going to use a lot in this. So here's the first one. These are in your reference table, so you don't need to memorize them.
Right. They're on table T.
They are on table T. Molarity is going to be moles of solute, which we learned in moles and stoic.
Right.
Divided by liters of solution.
Right. So even if you have 1,000 liters, 10 liters, 1 liter, a half a liter, the molarity of that solution is a number that can tell you comparatively how concentrated.
Right. So you're going to end up with moles per liter is your units, and it's going to be a capital M. You're going to see.
Let me draw that up there. Big old capital M. So it's like, big old M.
Right. Like we saw in the earlier on, we just did
12 M.
That
not
capital
12 million. It's not 1 million. It's 12 molar.
Molar. Capital M means molar.
Mm-hmm.
All right. Parts per million is something we're going to use when we have a very low concentration.
Mm-hmm.
We'll take the mass of the solute over the mass of the solution times a million.
Right. So this is better for more diluted things.
Yeah, very diluted things. When just a little bit is going to either affect something.
Right. For example, instead of doing like 0.000001 molar, we would probably do that calculation in parts per million.
And maybe like 10 parts per million or
whatever it may actually turn out to be. It can still give you a number that you can use to compare to other concentrations. Relative. That's the whole reason why we calculate concentration.
Sure. And then let's just do due diligence on the percent, because percent is always part over whole times 100. So in this case, we're going to deal with mass of solute over mass of solution times 100. Right. And those units are just percent by mass.
When we're doing the calculations on those, we'll have to be a little careful about finding out the volume or the mass of the solution. Because sometimes the way the problems are worded, you have to actually think and say, oh, wait, I should add these 2 things together to get the total
mass.
Right.
And that's why it's written this way, too.
Right.
And percent volume is the same thing. It's going to be the volume of the solute over the volume of the solution times 100, and you're just going to have units of percent.
It's not volume of solute divided by volume of solvent, because when you mix liquids, they don't always add up to what you think they should have added up to.
Right. It's the volume of the solution.
Right.
And so
total volume.
Total volume.
Yeah. Cool. So remember, with those 2%, you got to do the total on the bottom.
Sure. And here's part of the reason why this is so important, because this is what MoNaCo and I have to do in lab.
As a matter of fact, this is what we did to get ready for your lab number 1 with the precipitates. We had to make some solutions of what we know as concentrations that are A, safe to handle in the lab.
But there's enough stuff in there to react so you see it.
B, yeah, so you can see a reaction, and C, we don't need to make a bucket full of it. We only need to make a little bit. So we want to make sure we prepare our solutions with the known correct concentration
And
ahead
correct
of time.
volume.
And the correct volume, so that we don't have waste in the lab, because these chemicals, you don't necessarily want to pour them down the drain.
Not all of them.
No. So this is what we do.
So if we had an issue where we needed to make 3 liters, which is actually a lot,
Yeah, we never really
of
have
6 molar, capital M, KOH.
potassium hydroxide.
Right. So if we needed to do that, right in there is some information that
Well,
we know.
3 liters is easy to do. I can measure that with my volumetric flasks. Good to go. But 6 molar
Is where it gets
solutions.
tricky.
How
So let's
many
use,
is that?
so we're going to use this molarity equation, because molarity is going to equal moles over liters. So this I know. So now we can start figuring this out. I need to get 6 molar.
That's the molarity.
That's the molarity.
And
I am going to have some number of moles,
KOH divided by.
3 liters.
Okay, so now it's really just algebra, bruh.
Right, so to get moles of KOH by itself, I got to multiply both sides by 3.
3. So which means that I've got 3 times 6 is 18 moles of KOH I need to add to 3 liters of water, which is great, but I still don't know how much that weighs on my scale.
Right, but we learned about how to do that in
Gram formula mass.
moles and stoic. We learned
Yeah.
it. That's right. So now we need to convert to grams using gram formula mass. So we're going to take that 18 moles,
Times it by the
gram formula mass.
conversion factor, in this case 56 grams per 1 mole.
Right, and you want to tell me real quick how we got that 56 as a memory jogger?
I took the atomic masses of the K, the O, and the H and added them up.
Perfect. Good job.
And I set my conversion factor here so that my moles unit is going to cancel,
Right, because
introducing my grams unit.
correct. I'm in moles, so I got to have moles in the denominator.
Because the only way I can put a mole on a scale is by weighing it.
That's right, and I'm going to get 1,008 grams of KOH. I'm going to put that
Into the 3 liters of water.
And
so
then I
I
have
can
my
measure
solution.
a kilogram, almost, a little more of KOH, and I can measure 3 liters of water. I get
Right.
those 2 things, I mix them together, and I got my solution.
Sure. And of course, if I needed 1 liter of it, this would all change, and we'd go back and put
There
it
we go,
in
6 molar equals 3 equals moles over 1, and we need 6 moles, and so we do 6 times 56 instead of 18 times.
Sure. And we might not need 3 liters. This problem we did.
Maybe we needed a half a liter. You just change the number, you plug it, you chug it. It's algebra, bro.
That's it.
There you go.
Just a good way of using that equation. So, quick video, right?
Very quick
No, we
videos
almost done.
because calculations of concentration are literally plug and chugs. Algebra scales.
And so don't think that we don't expect you guys to know this by heart yet. This is going to take a little bit of practice. There is a bunch of practice, like 3 pages of this.
for sure.
To make sure we can do all these different kinds
Plugging
of
and
concentration.
chugging, reading comprehension. See if you can figure it out before you come to class, so that we actually have something to discuss if you
That
have
would
trouble.
be great. That would be great, rather than just copying what Mr. Milks writes on the board.
Right. Oh, I got you on mute. No, I don't listen to you, Bob. No.
Well,